Hey everybody, thank you for joining me. Happy Friday. Today is our catch-up day and a review and preview day of the laws of exponents. So our agenda is to please complete the do now, and then we're going to download our Kami extension, please, and complete makeup work. That will be step 1. Step 2 will be to complete the review on the laws of exponents, and step 3 will be to complete the preview on exponents. So what you do not finish in class, I'm going to ask you to complete on the Google Slides and submit for homework. So we're going to look at the do now, and it is solving a 2-step equation. And I want to remind you, you should be writing your game plan. And your game plan are the steps that you're going to do and the order in which you're going to do them. So if you remember, we undo subtraction by adding 7 to both sides. And we undo our multiplication of multiplying by 8 by dividing both sides by 8. So we want to draw a line right through the equal sign, and that reminds us that we're dividing the equation in half, and whatever we do on one side of the line, we have to do the same thing on the other side to keep the equation balanced. So I'm going to add 7 right underneath, and then on the right-hand side of the equation, I'm going to subtract 7. Add 7. And I know that 25 plus 7 is 32. Now a negative 7 and a positive 7 cancel. And the only thing I have left on the left-hand side of the equation is 8x. And I'm going to rewrite that right underneath next to the line. So the second step in my game plan is to divide both sides by 8. And I know 8 divided by 8 makes 1. So I have a 1x, and I don't have to write the phantom 1. And I know that 32 divided by 8 is 4. And that would be my final answer. Now I can always check my equation, and to check my equation, what I want to do is take my answer of 4 and substitute it back in to the left-hand side of the equation. So I have 8 times 4 minus 7. Now I need to literally use the order of operations, and 8 times 4 is 32. And 32 minus 7 is 25. And that is what the equation is supposed to equal, so I know it checks. So I'm going to ask you to download the Chrome extension Kami, and we'll talk about that next week. And now we're going to go into our first step of today's lesson, which is to complete the makeup work. So there are 4 assignments in Unit 2. 3 of them are on IXL, the diagnostic arena, the power of a power, which is F11, and then multiplying exponents, which is what I just assigned, and that's F8. And there's one homework on quizzes, and it is division of exponents. So please go on to Aspen and see what you owe. Everyone is going to need to complete this one. And I want to remind you're looking to reach a mastery level of 80% or greater, and then submit your. And then you are all set, and 80% or greater means that you'll get 100% for the assignment in Aspen. So please take a moment to look up in Aspen what you owe. And again, everybody's going to complete the multiply exponents on IXL. When you are ready, please join me on step 2. And our second step today is review time. So we're going to look at the laws of exponents to simplify each problem. So I want to remind you, when you are multiplying exponents and bases of the same, you add the exponents. So x to the 9 plus 5 is x to the 14th power. When you are taking the power of a power in problem number 2, you multiply the exponents. And 9 times 5 is 45. So our answer is x to the 45th power. And in problem number 3, we're dividing and bases are the same, so we subtract the exponents. And we always want to do our subtraction where the larger exponent is. In this case, 9 is greater than 5, so we're going to subtract in the numerator. And 9 minus 5 is 4, so we have x to the 4th power. So if you look at these problems, they were all very similar in numbers and variable, but each of them represented a different law of exponents. So on problem 4 now, we're using the division property, but you'll notice this time the larger number is in the denominator. So we're going to subtract in the denominator. And I know that 7 minus 3 is 4, so I have x to the 4th power in the denominator. And if I don't see a number in the numerator, it is the phantom 1. So I can add a 1. Okay, the next problem. We can use the commutative property of multiplication to organize our numbers together and our variables together. So I have a 2 times 4. And then I have an x to the 9th power times an x. And I want to remind you, if you don't see an exponent, you can just add the phantom 1. So the next thing we want to do is multiply our numbers, and 2 times 4 is 8. And then we add our exponents because bases are the same. And x to the 9 plus 1 is x to the 10th power. And that would be our final answer. In the last problem, we're going to do the same thing. We're going to separate or organize our numbers and then our variables. So the first thing we're going to do is simplify 10/15ths, and each of these is divisible by 5. So this becomes 2/3. And then for the variable, the larger exponent is in the numerator, so I'm going to subtract in the numerator, and x minus 5 is x. So the answer is 2/3 x. So the last problem you'll be completing in review time is a word problem. A lab technician draws a sample of blood. A cubic millimeter of blood contains 22 cubed white blood cells and 22 to the 5th power red blood cells. What is the ratio of white blood cells to red blood cells? Write in exponential form and without exponents. Okay, so we need to write a ratio, and the ratio is white blood cells to red blood cells. So the first thing I'm going to do is write my ratio in words. Okay, so we're comparing white blood cells and red blood cells. Now the white blood cells right here are 22, cubed. And that's per cubic millimeter. And the red blood cells are 22 to the 5th power. So please remember, when you are dividing and bases are the same, you subtract the exponents and you subtract where the larger exponent is. So this time it's going to be in the denominator. So in the numerator, we're going to have the number 1, and in the denominator, 22 squared. So the first task was to write that as in exponential notation, which is right here. And the next task is to write this without exponents, which means we need to multiply 22 times 22. So please take a second and do that work. And this is equal to 1/484. Our last step is our preview. So I'm going to ask you to study these examples and see what you notice. 9 to the 0 power equals 1. That's a whole number. 1/2 to the 0 power equals 1. 75 hundredths to the 0 power equals 1. And 962 to the 0 power equals 1. So if you have a calculator, you can always take a number, your favorite number, and raise it to the 0 power. And you're going to find any non-zero base or number raised to the power of 0 is always 1. So the last thing we're going to do is I'm going to ask you to watch a video about negative exponents. And I'm going to have you study a couple things to see if you can generalize. So please look at that table, and you can see that as you increase by 1 in your exponents, you're multiplying by 1 more 5. And when you go the other direction, you are actually dividing by 1 more 5. And so I'm going to have you look at this last slide. And what I like about this is it gives you the powers of 2. So you know 2 to the 0 power is 1. And 2 times 1 is 2. And 2 times 2 is 4. And 2 times 4 is 8. So again, the inverse operation of multiplication is division. So if we can go the other way, 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 divided by 2 is a half. Sorry, let me start over. All right, so if I'm going the other way, I'm going to divide 8 by 2 and get 4. I'm going to divide 4 by 2 and get 2. I'm going to divide 2 by 2 and get 1. And so that makes sense. I'm going to take 1 and divide it by 2 and get a half. And take a half and divide it by 2 or multiply by 1/2. I'm going to get a fourth. And then a fourth times a half or divided by 2 is 1/8. So I am hoping that you are starting to see some symmetry. 2 to the 3rd power is 8. And 2 to the negative power is 1/8. 2 squared is 4, and 2 to the negative 2 is 1/4. 2 to the 1st power is 2. we go. Oh, I keep picking that same color. And 2 to the negative 1 is just the reciprocal, and the exponent is positive. So when you have negative exponents, you flip the fraction or take the reciprocal and change the sign of the exponent to positive. All right. Well, thank you for working so hard, and have a great Friday. Enjoy your weekend.